Rosa, Monroe. Okay. Williams, Monroe, Rosa, Jones, Smith, Blackman, Ferguson. Smith, Blackman, Ferguson. Alrighty. We're going to move the screen. Okay, we're going to go ahead and get started. Let's see, share screen. Here we go. Okay. Okay, today is Wednesday, November 18th. We are going to have one more test, test 5. That's going to include chapter 4 and part of chapter 5. The final exam that will be due on the basically last day of exams, December 3rd. We're going to review for test 5 on Monday. So we'll finish with all new instruction this week. And then we will review for the final exam after Thanksgiving holiday, Monday, November 30th, and that'll be our last Zoom class. And so today we're going to cover 5.1 and 5.2. Any questions with that? Alrighty, let's get started. Okay, so we left off at lesson 5.1, and we were here at, let's see, can I zoom in on that? No. I'll do this though. This is actually easier than switching back and forth. Okay, so we're going to find an equation to a tangent line, graph the function, give a point, and graph the utility and of the tangent line and the point, and use tangent feature. So basically, all I'm interested in is writing the equation. So we're going to do problem number 69. This back out. And we have here f of x is equal to 3x squared minus the natural log of x at, and we want the tangent line at 0.13. Okay, so first thing we do is we got to find slope, right? Find slope, and we do that by finding the derivative to our function. So this will be going to bring the 2 down, right? Subtract 1. So this will be 3 times 2 x to the first minus the natural log, the derivative of natural log x is 1 over x. Okay, so now to find slope, basically once we find the derivative, then we put the x coordinate in there. So of our derivative, so that's f prime of 1 equals to 6 times 1 minus 1 over 1, and we get 5. So therefore our slope equals 5. Questions with that so far? Okay, so from here we apply the point slope equation, y minus y1 equals to our slope times x minus x1. So here our x coordinate is 1, our y coordinate is 3. So we're going to put in here y minus 3 equals to our slope, which is 5, times x minus x1, which is 1. And from here, try to get that out of the glare. From here, we go ahead and distribute the 5, simplify that. So that's y minus 3 equals to 5x minus 5, and then apply plus 3 to both sides. To put it in slope-intercept form, we get y equals to 5x minus 2. And that's our equation to the tangent line. Okay, questions with that? All righty, Cassidy. Standard. Okay, and that's all we're doing for lesson 5.1. We are finished with lesson 5.1. Any questions? Okay.
Can you go back to the top?
What?
Can you scroll back to the top?
Oh, yeah, sure. Okay, so we're doing problem 69. We got to find the tangent to this line right here. Okay, so first thing we have to do is find the slope, and we find the derivative, and we plug in the x coordinate into the derivative. So the derivative, we bring the 2 down, right? So that'll be 3 times 2 is 6x. The derivative for natural log x is 1 over x. So we plug 1 in, so that's 6 times 1 is 6, minus 1 is 5, so our slope is 5. And then we use the point slope equation, plug in our slope and our point, our x and y coordinates into our point slope equation, put it in slope-intercept form, and we have our equation to the tangent line. Any questions? All righty. So that's the end of lesson 5.1. All right, so let's take a look at okay. So here's lesson 5.2. We're dealing with the natural logarithm of a function, and we're going to work with integration. So we're going to use the log rule for integration to integrate a rational function and integrate trigonometric functions. All righty. So we said before that the derivative for natural log x is 1 over x. And if this is other than x, like u, then this would be natural log u is u prime over u. All righty. So So therefore, when we integrate 1 over x, that's going to give us natural log x plus our constant c. Or we can use 1 over u. We can also use u prime over 1 over u, and u prime would be considered du. So this is like u du, u and then u prime is equal to natural log x. So it's the inverse operation of the finding the derivative. We could also use u prime over u dx is natural log u plus c. All right, so we're going to use these formulas, and I'll put them at the top of the page as we are working through them. So I'm just going to put here d over dx for natural log u is u prime over u. So the integral of natural log u, 1 over u.
We can't see that.
Oh, yeah, okay. 1 over u du is, and we could also write this, and I tend to prefer u prime over u dx is natural log u plus c. All righty. Okay, so if we look at example 1, here we have the integral of 2 over x. So we could move that 2 out front and make that 1 over 2 times 1 over x. And so that's what we have. That's what we get here. And that's natural log x plus c. 2 times natural log x plus c. And then we can move the 2 up as an exponent. Here we have 1 over 4x minus 1. So here we want to, I'll go ahead and write this one out. The integral of 1 over 4x minus 1 dx. So here we have more than just x, right? So we need to find what u is. So the idea here is to get it to u prime over u dx. So u is 4x minus 1. So the derivative of that u prime is basically 1. This would be 1 minus 1, right? We bring the 1 down, 1 minus 1, that's x to the 0, and that's just 4. Okay. So we good with that? All right, so that means that we need a 4 here. So that means this will be 4x minus 1 is our u. And so we need a 4 here. But we can't just put a 4 there. So what we can do is put 4 over 4. And because 4 over 4 is 1, so we can split that 1/4 times 4 over 4x minus 1 dx. So this is still 1, and so now we can bring that 1/4 out front. So that's 1/4 integral of 4 over 4x minus 1 dx. And now we have our u prime over u, u prime over u. Okay, now we have our u prime over u. Okay, questions with that? So now this will be 1/4 natural log u plus c. So, and we said u is 4x minus 1. So this will be 1/4 natural log absolute value of 4x minus 1 plus c. And that's our answer to that integral. Any questions with that? Okay, so that's example 2. So if you need to go back over that again, it's in the book. All right. Okay, so moving right along. Okay, so we're going to take a look at problem number 20. And problem 20, it's this one here. Okay, x cubed minus 6x minus 20 over x minus 5 dx. Makes sense. All right, so problem 20. And so we're going to integrate x cubed minus 6x minus 20 over x plus 5 dx. Well, there's no way we're going to get u prime over u here. But what we can do is divide this using long division. So that's what we're going to do. So our divisor is x plus 5, and our dividend is x cubed, make this bigger, is x cubed. Now we need a place for x squared, or x cubed. We need a place for x squared, but we don't have an x squared. So this will be 0x squared. But we do need, and we need a place for x, which we have is a minus 6x. And we need a place for a constant, which is 20. Questions with that? X plus 5. Okay, so I can erase this now. All right, so what we want to do here is we want to multiply something times x to give us x cubed. Well, we can multiply x squared times x, and that'll give us x cubed. And another thing is if the sign is positive, our quotient's going to be positive. If the sign's negative, then our quotient's going to be negative. So this is positive, so our quotient's going to start off positive. So this is x squared. So we got to multiply x times x squared times x, and that's x cubed. And x squared times 5. So that's plus 5x squared. And so that's why we need a place for each exponent, because if we don't, then our lineup's not, what we're subtracting here is not going to line up. So we have to subtract that bottom row just like we do with numbers. So we distribute that negative, that becomes a positive, that's negative and negative. So we distributed the negative in that bottom row. We always do that on every step, because we want to cancel out these x cubes, this first term. You got a positive x cubed and a negative x cubed, they go to 0, right? They cancel out, they go to 0. And that's the whole idea. If we can't cancel these out, then something's wrong. So if the signs are the same, we add. If the signs are opposite, we subtract. So there's no negative in 0, it's just 0. So this will be a minus 5x squared. And then just like with dividing numbers, we bring the next term down. So that'll be negative 6x x. So here, this starts off with a negative, so our quotient has to have a negative in it, minus. And so we ask ourselves, what times x will give us 5x squared? Well, minus 5x, because minus 5x times x will give us a minus 5x squared. And so these will be the same signs temporarily. And so now minus 5x times 5 will be a minus 25x. Questions with that? Okay, trying to keep the glare out. Let's see if I can. Okay, that works. Okay, but we've got to change the signs. So we're subtracting again, right? So we distribute that negative, and so we change the signs of that bottom row. And now we've got a negative 5x squared and a positive 5x squared. The x squares go to 0, they cancel out. And here we got a negative 6x squared and a positive 25x squared. So we're going to subtract here, right? And we get a 19x. Questions with that? So now we this is positive, so our quotient's going to be positive up here. So what times x will give us 19x? Oh, first of all, we got to bring that minus 20 down. We don't want to forget that. So 19 times x will give us 19x, right? So 19 times x is 19x, and then 19 times 5 will give us 95. So that's plus 95. Again, we change the signs to the bottom row. And so the 19x's, the x's go to 0, they cancel. And we get negative 20 and a negative 95, so that we're going to add negatives this time. And we get a negative 110. Okay. So Clarence, make sure I get you on the attendance before we leave. Okay. Okay. So that means our integral is going to be x squared minus 5x plus 19. So this will be x squared minus 5x plus 19 minus 110 over, we have to take, that's going to, the remainder is going to be, that'll be the remainder over the divisor, x plus 5. X plus 5. And now this we can integrate. Okay. And so from here, this will be x to the 2 plus 1, right, over 2 plus 1, right, minus, so actually, before we do that, let's split this. So this would be the integral of x squared dx. So we're going to split this into each separate integrals. Minus, the 5 can come out, the integral of x dx plus 19, the integral dx minus, and then this 110 can come out, the integral of 1 over x plus 5 dx. Okay. Over here, there we go. Dx. Okay, so there we go. All right, questions with that? Okay, so now this, for this one, our u is going to be x plus 5, and our u prime is going to be 1, right? For here. Okay, so this will be x 2 plus 1 over 2 plus 1 minus 5 times x 1 plus 1 over 1 plus 1 plus 19x. So this is like x to the 0, right? So this would just be x minus 110 natural log u prime over u plus c. So now that's just going to be natural log u. Excuse me. Okay, so this will be x to the third over 3 minus 5x squared over 2 plus 19x minus 110 natural log, and we said u is x plus 5 plus c, and that is our integrand. That's our answer. Any questions with that? All right, we good? Can we go on to the next problem? Okay. So now we're going to backtrack a little bit with that, and we're going to look at problem 16 now. X squared plus 4x over x cubed plus 6x squared plus 5 dx. So we're going to look at 16 now. All right. Oh, there it is. All righty. Number 16. So we're going to integrate x squared plus 4x over x cubed plus 6x squared plus 5 dx. Okay, so we're looking at u prime over u, the integral of u prime over u dx. So we need to identify to give us natural log u, absolute value of natural log u plus c. Okay, so that's what we're trying to achieve. So we need to find what u is, and that's our denominator, x cubed plus 6x squared plus 5. Make that a better looking square there. There we go. And so our derivative to that, u prime, is going to be 3x squared minus 6 times 2 is 12x, and then the 5 goes to 0, right? So we'll just leave that 5 off. Okay, so, but we've got x squared. Oh, we've got to, let's see, what time is it already? All right, we've got to switch. This won't take long. All right, so that means we're going to have here, we need to multiply 3 into both. So this will be 3 times x squared plus 3 times plus 4x dx over x cubed plus 6x squared plus 5. But we can't just multiply 3, so we have to multiply 3 times 1/3. So that means we bring the 1/3 down out, and we can distribute that 3, and that'll be 3x squared plus 12x over x cubed plus 6x squared plus 5 dx. And so that's going to be equal to 1/3 natural log u, which is x, and we said u is x cubed plus 6x plus 5 up here. So that'll be x cubed plus 6x squared plus 5 plus c. And that's our answer. That's our integral. Okay, we're going to exit and come back real quick. So let's go ahead and do that. And see you here in just a moment. So we will be right back.